Hello everyone, I'm Jack Lee. Today I'll be introducing our research paper titled ICE-NeRF Interactive Color Editing of NeRFs via Decomposition-Aware Weight Optimization. First, let's see the concept of our research. In this study, we propose a method to perform color editing on a given area when provided with a user's mask and target color for a pre-trained NeRF scene. Here's our motivation. While there have been impressive methods proposed for recoloring 3D scenes, most of these methods struggle to target and recolor a specific area accurately like this when there are many similar colors within the scene. Additionally, recoloring often takes a significant amount of time. We chose to fine-tune parts of the pre-trained NeRF without fixing its weights to improve decomposition performance and reduce time cost. However, this approach presented two challenges. First, due to the nature of implicit representation, one weight can influence across the scene, and learning without proper consideration can't guarantee decomposition performance. Second, the view-dependent nature of many NeRF variants using a limited number of user masks cannot ensure multi-view consistency. To address these issues, we introduced AFR and SMR. Let's start with an overview. ICE-NeRF takes a recolor and frozen mask and pre-trained NeRFs as an input, and fine-tunes some NeRF weights to produce a recolored NeRF. During this process, the SMR module is used to render a single mask into multi-view. And AFR performs regularization on NeRFs' learnable weights that are less related to the recolor area to enhance decomposition performance. Now, let's discuss AFR. First, I will explain the activation field. Just as the original NeRF renders color for a specific view through volume rendering, we can replace radiance with activation from a specific layer in the original formula to render the model's activation for a particular view. Using the input and output activation map of a specific layer, AL-1 and AL, along with the recolor mask and frozen mask, we can understand that model's activation distribution for the recolor and frozen areas in the scene. This information helps us determine which neurons should learn more or less during the training process. SMR reduces the effort required for users to create masks from various views. As you can see, the process involves using a binary mask from the user and depth information from the trained NeRF to perform inverse projection in 3D space, creating a point cloud. This is then rendered from various views to handle occlusions that arise from changing views. We perform visibility-aware filtering to obtain the final multi-view mask. Now, let's quickly go through the results. ICE-NeRF can be applied to various NeRF variants. These results were obtained by applying our method to the TensorRF model. On the right, you can see the recolor and frozen mask used for recoloring. These results were achieved by applying our method to vanilla NeRF. In the top row, even with many similar colors, you can see that color editing is focused on the desired area. Here are the results of multicolor editing using multiple masks for a single scene. This is a comparison with previous recoloring methods. While traditional method performed well in recoloring the two scenes below, where there is a significant color difference between the object and the background, it was observed that our proposed method performed more focused color transformation on the first scene, where the object and the background have similar colors. Similarly, here's a comparison of results on the NeRF Blender dataset. To conclude, our ICE-NeRF allows for interactive recoloring using user mask inputs. While previous method takes several minutes to tens of minutes, our entire process completes in under a minute. Lastly, our proposed AFR and SMR method enable effective color transformation without unwanted color changes in other areas. Thank you. If you have further questions, please contact me at the email below.